Welcome everybody. Now we will find out how index and sequence we can create into an SQL. Before going to this slide, before going to this presentation, I will inform you that please learn about index, which is available in my previous lectures. Then you come here and do the index into the SQL, try it into your PCs and check it. Oracle Index is one of the effective tools for boost the query performance. However, in order to use it effectively, you must understand it correctly. To create a new index for a table, you use the create index statement as follows. Create index, index name, on table name, and within bracket column 1, column 2, etc. In this syntax, first specify the name of the index. The index name should be meaningful and includes table alias and column names where possible, along with the suffix such as table name, column name. Second, you specify the name of the table followed by one or more index columns surrounding by parentheses. By default, the create index statement creates a B-tree index. When you create a new table with a primary key, Oracle automatically creates a new index for the primary key columns. Unlike other database, Oracle does not automatically create an index for the foreign key columns. Here, follow a create index example. The name is member that stores the members data. First, follow the table name here like create table members, member ID int generated by default as identity, then first name varchar 100 which is not null, then last name varchar 100 which is not null, gender character 1 it is not null, either M or F, job is date, date of birth is date not null, email is a varchar 255 size not null, and primary key member ID. Now, suppose we often want to look up members by the last name and you find that query is quite slow. To speed up lookup, you create an index for the last name column. So, create an index like such a way that create index members underscore last underscore name underscore I on members within bracket last name. Here members is the table name on which the index is created. The name of the index is members last name I, and on which column the members is created, that is last underscore name column, the index has been appeared. To check if a query uses the index for lookup or not, you follow these steps. Run this table into your PC. First, create this table members, then create this member index, the member underscore last underscore name underscore I index. Then do this following steps. First, you select star from members where last name is equal to Harsh. If you run this query, there is no necessary to it will give you some output, and for this statement SQL query no need to it is not necessary the index of the table member. So to check if a query uses the index or lookup table or not, you follow these steps. First, add the explain plan for this cause immediately before the SQL statement. So first write down the query such as explain plan for select star from members where last name is equal to horse. This actually explains the execution plan into the plan table. The plan table is used to produce SQL explain plans. When SQL is submitted to Oracle and processed, an execution plan is created and used to process the SQL. It has 36 columns. Plan table has 36 columns. So you may use dbms underscore explain.display procedure to show the content of the plan table. So write down next, select plan table output from table dbms underscore explain dot display. It will display the following output. The first one is ID. At the 0th time, it will select the statement where it did not used at 0th time it is selected the statements where the table is not used. At the first time the table accessed by index row, the next time that is 0th one's index where it accesses the members, and at the same time it accesses the index range scan. So when we run the second query, it index range actually scanned and the index has been used. That's why the name is members underscore last underscore name I. And here we are showing that there are some bytes 258 like this. Bytes are actually estimates by the query optimization approach of the number of bytes accessed by the operation. It is the estimation of query optimization approach of the number of bytes accessed by the operation. The cost of the operation under the cost column as estimated by the optimizer's query approach. Cost is not determined for table access operation. The value of this column does not have any particular unit of measurement. It is merely a weighted value used to compare cost of reduction plans. So run this query into your PC and check the output is same or not. Creating an index on multiple columns. Previously we have created the index in the single column, that is here the last name. Now we will create on the multiple column. So create index member underscore name underscore I on members within bracket last name comma first name. So here the columns will be affected on last name and first name. The following query finds the member whose last name starts with letter A and first name starts with letter M. So this one, the first one, the create index members underscore name underscore I on members last name first name, and the following query the select star from members where last name like A% and first name like M%. So for this query it is not necessary to run to access the index. So now write the query to access the index. Explain plan for. Select star from members where last name like A module and first name like M module. So this will give you access on the index range scan. In the last query, select plan table output from table dbms underscore explain dot display. So this query will show you the right hand side output where the byte size is this, cost is 0, this. So it shows that when we use the explain underscore plan for, and that time if we access the last and first name, then this type of output will show and it will access the index range scan. To remove an index, to remove an index you use the drop index statement. Drop index then index name. For example, drop index member underscore last underscore name underscore I index actually drops this index from your database management system, and you will learn more. You can learn more that about how to drop an index in another tutorial, where you have to find out that to change the index you have to first drop the index and then you have to create the index. Create sequence. What is sequence? A sequence is a list of integers in which their orders are important. For example, if we write 1 2 3 4 5 and 5 4 3 2 1, these two are totally different sequence even though have same members. But first one is 1 2 3 4 5 is in ascending order, and the second one is 5 4 3 2 1 is the descending order. So how to create this sequence into our SQL? To create the statement sequence, write down the create sequence statements, which allows you to create a new sequence in the database. The syntax is create sequence schema name dot sequence underscore name, and then increment by interval. Start with first number, max value, it is no max value, or you may use max value. Mean value is mean value, or you may use no mean value. Cycle is either it is cycled or no cycled. Cache is cache size or no cache size, and order is either it is in an order or not in order. Specify at first the name of the sequence after the create sequence keyword. If you want to create sequence in a specific schema, you can specify the name in along with the schema name dot incremented by. So here our schema name was schema underscore name, and the sequence name is sequence underscore name. Then incremented by is actually specify the interval between sequence numbers after increment by keyword. The interval can have less than 28 digits. It also must be less than max value minus mean value. So the interval should be max value minus mean value, less than max value minus mean value. If the interval is positive, the sequence is in ascending order, that is 1 2 3 4 5 like this. If the interval is negative, the sequence is in descending order, like -1 -2 -3, such a way. The default value of interval is 1. If you do not give the value anything into the interval, then the default is 1. The next one is start with. It actually specify the first number in the sequence. The default value of the first number is the minimum value of the sequence for an ascending sequence, and maximum value of the sequence for an descending sequence. Keep it in mind that the default value of the first number is the minimum value of the sequence for an ascending sequence, and the maximum value of the sequence for an descending sequence. That means from which part the sequence will start. Then the max value. It actually specifies the maximum value of the sequence. The max value must be equal to or greater than first number. Specify after the start with keywords. No max value. Actually, the no max value is used to denote a maximum value of 10 to the power 27 for an ascending sequence, or -1 for an descending sequence. Oracle uses this option as the default. So the default value is 10 to the power 27 or -1. Mean value. Specify the mean value of the sequence. The mean value be less than or equal to the first member and must be less than max value. no min value. The no min value is indicate a minimum value of 1 for an ascending sequence or minus 10 to the power 26 for an descending sequence, and this is the default value. The next one is cycle. Use cycle to allow the sequence to generate value after it reaches the limit. Mean value for a descending sequence and max value for an ascending sequence. When an ascending sequence reaches its maximum value, it generates the minimum value. On the other hand, when a descending sequence reaches its minimum value, it generates the maximum value. The next one is no cycle. Use no cycle if you want the sequence to stop generating the next value when it reaches its limit. Actually, this is the default value. Cache. Specify the number of sequence values that Oracle will pre-allocate and keep in the memory for faster access. The minimum of the cache size is 2. The maximum value of the cache size is based on the formula that ceiling of max value minus min value. That is the ceiling value of max value minus minimum value, and it should be divided by the increment. In case of a system failure event, you will lose all cached sequence values that have not been used in committed SQL statement. The next one is order. The order to ensure that Oracle will generate the sequence numbers in order to request. This option is useful if you are using Oracle real application clusters. When you are using exclusive mode, the Oracle will always generate sequence numbers in order. And the last one is no order. The no order is used if you do not want to ensure Oracle to generate sequence numbers in order to request. This option is default in Oracle. Now let's take some example how to create an sequence. Here we have written that create sequence id underscore seq incremented by 10, start with 10, minimum value is 10 and maximum value is 10. Cycle cache 2. So this statement actually creates an ascending sequence called id underscore seq, which starts from 10, incremented by 10, minimum value is 10 and maximum value is 100. Now to get the next value of the sequence, you use the next val pseudo column. Select id underscore seq, that is the sequence name, dot next val from dual. It will return you the next val is 10 on the right hand side. Here to get the current value of the sequence, you use the car value pseudo column. Select id underscore seq dot car val from dual. So it will also return 10 because the current value is 10. Next, the select statement, if we use next val repeatedly, like such a way that select id seq dot next val from dual, connect by level and which is less than equal to 9. So the output will be from 20, 30, 40, 50, 60, 70, 80, 90 and 100. That is 9 rows will be selected. Because we set the cycle option of the idseq sequence and the next value of the idseq will be 10. So select idseq dot next val from dual will start from the next value of the start value and the output will be from 20. Now If we like to use this sequence in a table column example, so prior to Oracle 12c, you can associate a sequence indirectly with a table column only at the insert time. But here, look the example. First, we have to create a new table called task. Create table task, ID, number, primary key, and title varchar 2, now which is not null. Second, you create a sequence for the ID column of the task table. Create sequence task underscore ID underscore sequence. Third, you insert data into the task table. Insert into task ID title. The values are like this. Create task ID sequence.nextval. Create sequence in Oracle. So values is in the next time task value sequence next val, examine sequence values. So here the task ID sequence will automatically generate the next ID. So there is no chance to give the duplicate ID into the insert column. So this sequence actually helps you to generate the primary key and obviously there is no duplicate value without any duplicate value. Finally, the query data from the taskbar table is like this. Select ID comma title from the task. If we show the value, then it will show that ID starts from 1 and incremented by 1 to 1, and we have inserted two value 1 and 2. So in the time of create sequence, we have told that the default value of interval is 1 and the default value of start is also 1. That's why here the select in the next value starts from 1 and it increments by 1 by default. Now, the alter sequence statements allow you to change the increment, minimum value, maximum value, cached number, and behavior of a sequence object. So, keep in mind that alter value only helps you to change the increment, minimum value, maximum value, cached number, and behavior of the sequence. The syntax of the alter sequence is like this: alter sequence, then schema name dot sequence name, and incremented by this, max value this, mean value this, cycle this, cache this, and order this. So all the parameters have the same meaning as described in the create sequence as described in the create sequence syntax. When you change the sequence attributes, Oracle performs some validation behind the scenes. For example, Oracle will issue an error if you change the maximum number of sequence to a value that is less than the current sequence number. If you like to change the sequence at a different number, you have to drop the sequence first and then you have to recreate it. You cannot alter the sequence in case of different numbers sequence. So the drop sequence statement allows you to remove a sequence from the database. The basic syntax is drop sequence, then sequence name dot sequence underscore schema name dot sequence underscore name. In this syntax, specify the name of the sequence that you want to remove after the drop syntax keyword. If you don't specify the schema to which the sequence belongs, Oracle will remove the sequence in your own schema. The sequence that you remove must be in your own schema, or you need to have the drop any sequence system privilege to remove and sequence in any schema. The drop sequence statement is also useful in case you want to restart a sequence. For example, if you have a sequence with the current value of 100 and you want to restart the sequence with the value of 50, Then you can drop the sequence first and then recreate it with the start value of the 50. So through the alter sequence column, the alter sequence syntax, you cannot remove the order of this, you cannot remove the new, you cannot create the new sequence actually. If you like to just change the start value, then you have to first drop the sequence and then create the sequence. Here is an example to drop the sequence. Drop sequence id sql is the sequence name. So as we do not put the any schema name, that's so id underscore sql must be into the same schema where you are working on. So I like to thank you, and before thank you I want to say that you please try this into your machine PCs and look how it works actually. Thank you.